is the applications of various geotechnical techniques that are used to re-engineer existing soils to improve their engineering characteristics.
There are several issues that are related to ground improvement technology that we can improve. First technology is for jet grouting, which is there is a hydraulic fracture happen. Secondly, for vibrator replacement, we need to run many tests when we done this method. Thirdly, for dynamic compaction, we need to do a constant site monitoring, and also we need to deal with the clayer soil and also silt soil. Let's look at the issue together. For jet grouting issue, it can be seen that there is hydraulic fracturing interferes with the orderly compaction process and can cause damage in the building under which grout is injected and a nearby building. Next, for vibro replacement, a comprehensive analysis of the soil profile is needed with continuous sampling or in situ testing. The tests are plate load test, pressure meter test, standard penetration test, and lastly, seismic cone penetration meter test, or more known as SCPMT. And for dynamic compaction issue, a constant monitoring is required to check for the formation of crater, ground heave, ground vibration, induced settlement, and pore pressure development during the operation of this method on the site. But this method becomes more complicated in silty and clayer deposits below the groundwater due to its relatively low permeability.
The first technique of ground improvement is by using vibro stone column method. Vibro replacement stone column is a ground improvement technique to improve load bearing capacity and reduce settlement of the soil. The stone column consists of crushed coarse aggregate of various size. Vibro replacement is the process of constructing stone column using a vibratory probe. After the probe penetrates to the depth of treatment, stone fill into the hole from the ground surface to the tip of the probe. By using this method, it offers an economical alternative to piling and also can be carried out to the depth up to 15 meters, but a comprehensive analysis of the soil profile is needed with continuous sampling or in situ testing. Second technique is jet grouting method. Grouting defined as an injection of a special liquid or slurry material called grout into the ground for the purpose of improving the soil. Jet grouting is a modern, fast and effective method applied in the soil for the creation of deep foundation elements. It is one of the most successful systems today in achieving this result. Jet grouting is a technology in which high pressure jet of swimming grouts are discharged sideways into borehole walls to simultaneously excavate and dominate with the soil. By using this technique, the ability to drill underneath obstacles and a solidified zone which are hard to access, and it is most utilizing system, but it is very difficult to control heave. Last method is dynamic compaction or heavy tamping. This technique is mainly used for deep compaction and literally involves dropping a weight that is suspended from a crane onto the ground. The technique involves repeatedly dropping a large weight from a crane. Drop height typically varies from 10 meters to 40 meters, and these techniques cost less than traditional method, and it may reduce secondary settlement in cohesive materials. The disadvantage is it could damage the structure and high mobilization cost.
Infrequently encountered issues. The first infrequently encountered issues in ground improvement is liquefaction. Liquefaction occurs when a saturated or partially saturated soil substantially loses strength and stiffness in response to an applied stress such as shaking during an earthquake. Use vibro replacement, one of the method of reducing liquefaction potential because they are perform vibrations. They increase the compactness of the soil foundation. Secondly is landslide. Landslide occurs when force acting down the slope exceed the strength of the earth of the material that compose the slope. To prevent landslide, grouting rock joints and fissures need to be done to reduce the flow of water along the path and discontinuities in the rock. So these are the other new technology that can also be used to strengthen the soil.
Soil stabilization, membrane and vacuum consolidation.
That's all from us. Thank you.